Hello everyone, my name is Matthias. I'm the co-founder of Pragma and core contributor of Madara. And today I'm going to talk about how you can redefine how oracles are and the whole design of oracles using Cairo and storage proofs. So it might get a bit technical, but I'll try to make it as understandable as possible. So first let's have a quick recap about what oracles are. For most people, when you tell them what do you think an oracle is, they'll tell you, okay, it's some trusted off-chain infrastructure that gives you a price of an asset. And I mean, yeah, so far it has mostly been this. But we believe that we can totally redefine that definition, which is, I mean, getting a price of an asset on-chain is necessary for a lot of use cases, but I mean, it's not, you cannot build a lot of great apps, and we feel like the whole DeFi space has been a bit hindered by this, whereas in reality an oracle could be way more than that. It could be like a provable environment where people could build these complex financial data feeds in a provable way and use that to power way more complex kind of apps and replicate what we have in TradeFi with hedge funds, credit markets that do run on way more complex models than what we have right now in DeFi. So some examples of these, just to illustrate. So you have like Risk Oracle, which right now doesn't really exist. You have Volatility Oracle, so both realized and implied volatility. Those we already have, so on-chain in Cairo. Dynamic CDR, so like in lending protocols, you have a bunch of parameters that right now are hard-coded and not dynamic, whereas they should be based on market conditions. On-chain yield curve, we already have that as well. It's very useful for fixed rate interest lending and for many other use cases in credit markets, reward assets. Dynamic spreads, options purchasing votes, volatility indexes, liquidity oracle, dynamic liquidations as well. Basically, yeah, just going one step further when you design your DeFi protocol and making things dynamic and not rely on governance to update a set of parameters like debt ceilings, spread, liquidity. All of these things should be based on more complex data feeds, which is not possible right now, or at least not in a provable way. So how can we actually do that? Let me first introduce to you a bit about Madara. Madara was this idea that we wanted to build an easy stack for people to deploy app chains on Starknet with the whole Starknet stack. So this is like the architecture of Madara, like in very high level. So you have a transaction pool, then you have the sequencer, so it's a decentralized sequencing layer, right? There is a consensus because it's built with Substrate, so the Polkadot development framework. And we created this compatibility layer for Starknet. And so the sequencer validates the transaction, runs the Cairo VM, produces blocks, and then send that to the prover, and the prover just pass things to L1 or to L2, depending if you're an L3 or an actual L2. So why that? We wanted to have a decentralized sequencer, also experiment with Substrate. Substrate is a very powerful framework written in Rust. And just the use of Rust makes it so great to customize everything to your needs, hashing functions, storage layout, and all this kind of stuff. And of course, liveness and censorship resistance, that was like very important for anyone building a decentralized Starknet app chain. So Madara is not in production yet. It's working quite well. We've achieved like almost full compatibility with Starknet RPC. Soon transaction simulation as well. Now we're working on the integration with Sharp, with the verifier in Cairo as well to be able to build L3s. We're experimenting a lot and we have a bunch of contributors, over 50 contributors experimenting and helping with the development of Madara, especially around experimenting with different consensus algorithm. We have a team working on hot stuff. We're experimenting with Tendermint as well to achieve faster finality and just to experiment with Substrate in general. Encrypted mempool, so Radius is actually working on implementing that into Madara, which can be really useful for privacy, especially for us at Pragma, where we don't want data providers to like see what each other is publishing. And then data availability layers, it's quite easy to implement a few of those. So Celestia is working on it, Polygon Avail, the Kaiser Labs team implemented Bitcoin data availability with Madara. So that's pretty much it. It's a very community project where anyone can come, build your own thing, experiment with your own decentralized custom Starknet, basically. Okay, so where does that come from? Come into play when we talk about Pragma and oracles. So the oracle we have right now live on Starknet for 1.5 years is great, but how can we achieve higher frequency? Ideally, we would want like 100 millisecond updates. The second thing is cross-chain data feeds without losing the provable aspect, right? You still want all the computation to be provable. So what I mean by that is that it should be run as Cairo programs, but you want to make these data feeds accessible to other rollups. Then permissionless data providing and quote engines are also a very tough topic that if you don't have a lot of customizability and you want to do it at the protocol level. So Pragma X is pretty much that. It's a mix of a few things. You take the Cairo VM, which gives you this provable environment, this execution layer, provable execution layer. You have substrate, you have a decentralized sequencing layer. And the last element in the mix, which I didn't talk about a lot yet, is Herodotus, so storage proofs, which in a few words is just a very efficient way to do data bridging in a trustless way using how the state is stored in Merkle trees. I won't go that deep into that, but if you want, it's very interesting. And with all of this, you get verifiable data. Yeah, so here I have an animation of how all of this works, because now we've been theoretical, but oh no, that's not the that's not for right now. So this is okay. So if a user is on Ethereum and wants to do a borrow on the dApp, he will trigger some borrow, and then the dApp will tell Herodotus, hey, this user needs this data feed. Please give me the storage proof. At least prove the storage proof and verify it. So Herodotus will get the proof from the Pragma chain, which is, again, a decentralized custom Starknet. Herodotus would then prove the storage proof, basically to make it more efficient to then verify on Ethereum. Because if you were to directly go from storage proof to Ethereum, it would be very expensive because of the curves being used. So you need to snarkify your storage proof first. Then the state truth. The state truth is being passed from the Pragma chain to Ethereum. That can be done in different ways. So the most trustless way here is actually proving the consensus. So light client bridging, basically, but like it's a very hard topic. There are a few teams working on this, like Succinct, even Herodotus is working on it as well. But it depends on which consensus you have, and some are easier to do light client bridging with than others. But otherwise, you can also use an MPC protocols, and basically the validators of your network sign the state root or the block hash, and then you can just verify that signature on Ethereum or any target rollup. And finally, Herodotus calls Ethereum and verifies the storage proof, and there is RLP decoding to get the underlying data. And at this point, the dApp can actually read the underlying data feed from the fact registry. And the very powerful thing here is that on the Pragma chain, you could have done like a lot of computation, like computing implied volatility, which is not something you would do on any EVM chain right now. You could do it in a provable environment, because the last step is that we verify the start proof. So the execution, all the computation that happened on the Pragma chain will be verified. Like, you don't have to trust that it happened correctly. It will be verified at some point, maybe not as soon as you consume the data, but a few minutes after at worst. So that's pretty much of the whole infrastructure that we're working on, and we've been working on in the past 6 months. And we're getting there pretty much. So where are we at right now? We did the whole Cairo 1 migration of the chain, so the yield curve, realized volatility, all these data feeds, and of the whole Pragma protocol itself. We launched the Pragma X testnet, so what I just mentioned. The testnet is already live, and I will do a demo right after. And the next step, of course, is Istanbul, where we hope to show even more, especially around permissionless data providing and the code engine. So let's, if you can play the video, please. All right, so that's the Madara app. So Madara app is like a pretty cool thing that has been built by the community again, where you can basically run your node. And so you run your node, it will take some time, but you run your full node in like one click. You can see all the other full nodes are synchronized within the network. So this is like Sharingan testnet, which is like public Madara testnet. And you have a bunch of apps on the side. So you have a faucet, you have an explorer, you have like dojo games, for instance. And here the main ones that we're interested in are Apibara, which is a StarkNet indexer to basically index all of your data very easily. It's a very powerful software. Okay, here the full node has started. So we start the Apibara indexer. It indexes the whole chain. Then we start the Pragma app. So it does three things. The first thing is this thing called the sync Postgres, which basically takes the data being indexed by Apibara and puts it into a Postgres database. Then we have some scripts that are running Python scripts to deploy the contracts, declare the contracts, and once the contracts will be declared and deployed, it will start publishing some data. And all of this is one click, right? You did not have to do anything, and everything is interacting with your own full node, so you have like sovereignty about what you're doing. So here it's deploying the contracts. It might take some time again. And everyone can actually use that. The Madara app is open source, welcome contributors a lot. There is like much things to do. Anyone could also add their own apps to this. Here we experimented with a few apps, but imagine a future where there will be like a dozen and dozen of apps where you can interact with on StarkNet directly or on any StarkNet app chain. Okay, so it will take some time, but we'll get there. And as soon as now it's publishing some data. As you can see here, okay, it's not readable, but you can see data being published. And then we go to the Pragma app, which is the front end is also deployed as part of the app. And you can see in real time the data feeds being updated with a graph, with like the all the pairs. Here it's just like a simple median, but we could also display realized volatility, TWAP, VWAP, and all of this in a completely trustless manner. So, yeah, I think that's pretty much it. Speaks for itself, and I guess we'll take some questions. Any question? No. All right. Well, that means it was understandable. Thank you very much.